Models. You see some of the models are communicating with each other. You know, a big application might have a single shared model, or the models might be split off into pieces to be used by sub-MVCs, okay? But that's the only kind of communication you have there. All other communication is either the structured view communication we saw in MVC, or it's using MVCs as part of the view of another MVC. Any question about that? So we definitely don't want to be having designs that look like this, okay? Where everybody's talking to everybody. We can't tell who's talking to what. It's just impossible to debug a program like this, and it doesn't scale. You can't build really big programs this way. It just becomes impossible to know how touching anything would break everything, right? So we're definitely not going to be doing that. Okay? Okay, so that's MVC. No questions about that? All right, on to Objective-C. So Objective-C is a strict superset of C. So everything you can do in C, you can do in Objective-C. Okay? And we'll do a lot of C things in this class. We'll do a lot of object-oriented stuff too, but we're going to be doing a lot of C things as well. But there's obviously a few things that you want to think differently about because you have object-oriented stuff added onto a language. And we're going to talk about one of them today. In addition to showing you a little bit of the syntax, we're going to talk about one of these think differently things about Objective-C that's different than C++ or Java, which is properties. Okay, and I'm not going to read through all this. I'm just going to show it to you. But properties are basically how we access our instance variables, right? Everybody know what I mean by, raise your hand if you know what I mean by instance variable. Okay, good. So pretty much everybody. So we want to access the instance data of our objects. And normally in Java or in C++, you just have some syntax to access them, and you just access them. In Objective-C, we don't do that. Okay? In Objective-C, we have what's called a property. And a property is basically a setter method and a getter method. And that's how all access to the instance variable goes, through a setter method to set the value and a getter method to get it. And some people who maybe are kind of performance junkies might say, oh my gosh, every instance variable I have to call a method to set it or get it. But remember, you're building for a user interface system here. When the user touches down, that's taking a million code, you're executing a million instructions there in that amount of time. So having a few extra setters and getters is completely irrelevant, right? So it's the old Knuth thing, right? You don't want to optimize things that don't need to be optimized, okay? You want to optimize the things that are taking a lot of time, and accessing instance variable turns out not to be taking a lot of your time. So let's look at what it looks like. Don't get freaked out here by seeing this syntax. It's all new, so it's going to take some getting used to. In Objective-C, every class we have, and the class I'm going to show you today is in our essentially our model that we're going to build for our card game matching app. We're going to have a card and a deck, and we're also going to have a subclass of card called playing card and a subclass of deck called playing card deck. Those are the four classes going to be in our model to start. And so I'm going to show you, in today's lecture, I'm just going to show you card, only card, and then on Wednesday I'll show you deck and playing card, deck and playing card. So every class in Objective-C, you have a header file, card.h, and you have an implementation file, card.m. Okay, this would be just like in C++, you might have .h and .c or whatever. This is .m. M, I guess, is for implementation. I don't know, but it's M. And so you have these separate things. The difference here is card.h is the public API. That's what your .h file is. It's your public API. Card.m is your private API and all your implementation. Okay? Don't get confused about .h and .m. All .h is your public API. That's all it is. It's what methods in your class you want to make public so that other people can call them. Okay? So let's see what the syntax looks like. In your public API, you must say who your superclass is. Okay? You are not allowed to make your superclass be a secret. Okay? It has to be public, so we have to put it in the header file. And you can see the syntax we use is @interface, the name of our class, which should always match the name of the file, by the way. Card.h should always have the interface for the class card. And then a colon, and then your superclass. Now, the superclass of the card class is NSObject. NSObject is in the Foundation framework. And it's pretty much the root class of every single class in all of iOS, including all the classes you write. Okay? It's this kind of basic class. We'll talk about it when we talk about foundation, but it's going to be the superclass eventually of every single class, right? Everything eventually inherits from NSObject. Now, on the implementation side, it looks very similar, but instead of saying @interface, you say @implementation and the name of the class. And here you don't specify your superclass, okay? Because you're only allowed to specify that once, and it's public, so it goes in your header file. Notice at the bottom of both of these, a little @end. Do you see that? Okay, that just means that's the end of the interface or of the implementation. Okay, so all of your public API goes inside this @interface block, @interface end, and all of your implementation, your private implementation, goes in the @implementation part. Now, if you import, if you have specify your superclass here, you have to import it, okay, which is like #include. It's a little more powerful than #include. In fact, it's a lot more powerful, as I'll talk about in a second here. But you must import it, otherwise the Objective-C compiler won't know what that superclass is. So you have to obviously import your superclass. However, we don't usually, when our superclass is something that's in iOS, we don't usually import just that class's header file, which in this case is foundation. We actually import the entire framework. Okay? Now you might say, whoa, that's inefficient, a huge framework thing. But of course, this is all highly pre-compiled and optimized. And in fact, in iOS 7, the syntax for this is really to say @import foundation. That means I'm going to use all the public classes in the foundation framework. iOS 7 still supports the old import foundation /foundation.h, so you can use that if you want. Now, on our implementation file, we have to import our header file, obviously, okay? Because our implementation file needs to know what we're committing to publicly in terms of our API. So we have to import that. Makes perfect sense. We can also have private declarations, okay? Declarations of properties and methods that are private inside of our implementation file by putting this little @interface, name of our class, open parentheses, close parentheses, okay? And then @end. So we can have a little space here where we can put little private declarations. Now, Objective-C does not require you to declare something before you use it in a file. You know what I mean by that? You know, there's a lot of languages, you have to declare a method before you can call it, right? But you can do it out of order in Objective-C. You can implement a method here that calls, you can implement method A, calls method B, and then method B is implemented down here later in the file. Okay, so you don't have to declare method B first, then implement method A, and then implement method B. So this little private @interface we're mostly going to use for properties. Okay, because when we declare a property, as you'll see, that setter and getter get written for us. So let's see what that looks like to declare a property. So here's a simple property. It's called contents. So this is the contents of the card. This is what's on the card. So this might be ace of clubs. Okay? And because this is your first day, we're going to make the contents be very simple, just a string. Okay? So these cards, they could be like a flashcard, maybe, for learning a foreign language. Maybe this, the contents are the word that you're trying to learn, and maybe it's a flashcard of images where this contents is the name of some image, and it's up to the UI to display an image that matches it. Or in the case of our playing cards, we're going to have this be like literally the character A and then the character clubs, because there's a Unicode character clubs, so it would be A clubs. That would be the content. So this is the contents of the card, what's on the card. And you can see that it's an NS string star. You see, @property is how we're going to declare that we need storage per instance of card. In other words, every card has its own contents, and it's going to be a string. And so we say property NS string star. Now, it's important to understand that in Objective-C, all objects, all of them, live in the heap, and we have pointers to them. Okay? There's no such thing as making a object on the stack or anything like that. Okay, they're all in the heap. Everyone knows what the heap is. Any questions about that? That's just where you allocate free memory. So all objects are there. What's really cool about Objective-C is Objective-C will manage all that storage for you. It will allocate it for you and free it for you. Okay? Now, how does it know when to free it? And the answer is this strong thing. You see the word strong there? Properties can either be strong, like this one, or weak. Two things, strong or weak. Okay, and all pointer properties have to be strong or weak because the Objective-C has to know what to do with the memory in the heap. Strong means keep the memory for the thing this points to in the heap as long as I or anyone else has a strong pointer to it. Okay, so this is called reference counting. It's not garbage collection, it's reference counting. So the Objective-C is going to keep track of every single strong pointer to an object in the heap. And as long as at least one strong pointer exists, it's going to keep that thing in the heap. As soon as there are no strong pointers left, it will free the memory out of the heap instantly. Not garbage collect it later, but actually instantly reclaim that memory. Okay? So this is probably new to you. You're probably used to like garbage collection in Java, for example, or explicit memory management in other languages. This is called automatic reference counting, and it's awesome. It's really very predictable. It's much better than garbage collection because the garbage collector can come along later and wreak havoc on the performance of your application as it goes and collects things from the heap. This is very predictable. You know exactly when things are going to be released. It's when there's no strong pointers left to it. What would it mean if this was weak? Okay, if you have a weak pointer, that tells Objective-C, okay, I have a pointer to this thing in the heap, and keep it in memory as long as someone else has a strong pointer to it. But as soon as no one else has a strong pointer to that thing, it gets freed from memory, and this pointer, if it was weak, gets set to nil. Nil means this pointer doesn't point to anything. Okay? Nil is the same as 0. Okay? In other languages, you're probably afraid of nil pointers, okay? Because you dereference a nil pointer, crashes your program, right? In Objective-C, you can send messages to nil pointers even, and it will not crash your program. In fact, if you send a message to a nil pointer, it will not execute any code, obviously, because there's no instance there, and it will return 0 from whatever. If that message had a return value, it'll return 0. So you have to be a little careful of messages that return structs, okay? But as long as it returns a primitive type or a pointer, it'll just return 0. So this is going to take getting used to. The fact that we are going to program knowing that we can send messages to nil, to pointers that are nil, and that's good. We'll actually make our code work nicely, and we'll use that to our advantage. And that is definitely going to be a change for you who are used to, if pointer's not nil, then send message all the time, right? Protecting against crashes. You don't do that in Objective-C. You just don't code that way. Okay? So this pointer could have the value nil, N-I-L, which means it doesn't point to anything. Right? So if you have a strong pointer and it points to something and then you set it to nil, now that strong pointer doesn't point to that thing. As long as no one else points to it, you can clean up that memory. Objective-C will clean the memory up for you. Or if you have a pointer, it points to something in the heap, and you make a point to something else in the heap, then you no longer have a strong pointer to that other thing in the heap, and as long as no one else does, it'll get cleaned up. Okay? And remember, weak not only cleans it up, but it sets your pointer to nil, because you only wanted a weak pointer. You only wanted to point to that thing as long as someone else does. Okay? So that's the strong versus weak. The other thing we're going to put in this little parentheses is nonatomic. Okay? Nonatomic means calling this setter and getter that go along with this property is not thread safe. Okay, so you can't have two threads trying to set this property at the same time. Why do we say nonatomic here? Why do we want this to not be thread safe? Because the way we do multi-threading in iOS is not by having a single object that multiple threads are setting on. We usually have a separate set of objects that are running in another thread, like your model, and then other than your UI stuff is running in the UI thread, and they're talking thread to thread. Okay? So we don't need this. And not only that, what's going to happen here when we do this @sign property is Objective-C is going to create that getter and setter methods that I told you about to set this contents automatically for us, and we want them to be simple. Okay? And this is what they're going to look like. We want them to be simple. If we don't say nonatomic, there's going to be all kinds of locking code in there, right? If you have multiple threads and you're allowing multiple threads to access the setter and getter here, then you need locking code. And we don't want locking code.